afternoon, everyone, and many thanks to IST-Africa for the opportunity to present this work. My name is Nikhita Madhanpall, and I am a DARA Big Data Fellow at the Office of Astronomy for Development in Cape Town, South Africa. This afternoon, I will present the initiatives of a big data analytics capacity development program in Africa, which has been running since 2017. This is a brief outline of this presentation. I will introduce the partner institutions, briefly discuss the radio astronomy context of the program, then talk a little about the motivation as well as the objectives of the program. I will present the African Research Cloud that is being used to support the project, as well as the actual initiatives of the project, namely the Big Data School and hackathon events which we implement, and we'll end with some concluding remarks and future implementations of the project. The institutions which collaborate to implement the initiatives of the program are DARA Big Data, where DARA stands for Development in Africa with Radio Astronomy. This project is jointly funded by the UK Newton Fund and the Department of Science and Innovation in South Africa, and is led by a team at the University of Manchester in the UK and the South African Radio Astronomy Observatory, SARAO. Other partners are the Inter-University Institute for Data Intensive Astronomy based in South Africa, and the Office of Astronomy for Development, which is an office of the International Astronomical Union. So the Square Kilometre Array is a radio telescope that is being built in South Africa and several African partner countries, as well as parts of Australia. And when completed, will be the largest scientific facility in the world. It's acknowledged as one of the biggest big data machines globally, and will require new and innovative big data solutions and relevant technical skills, which has resulted in a drive for building capacity in this area and has resulted in projects such as DARA Big Data. This significant investment in big data infrastructure on the African continent has also been highlighted as a major driver for economic development by the countries of the SKA-Africa partnership. Data science and big data skills development in Africa is crucial to allow for African participation in the technological advances that are resulting from the fourth industrial revolution. A data science research community in Africa will also allow for Africans to form data-driven solutions to Africa's most pressing development needs, such as improving access and equity in healthcare, working toward food security, and reducing the impact of climate change. African scientists are best suited to take on these local challenges as they best understand the social, cultural, and political contexts. However, academic institutions in Africa have only recently begun to create these structures and training programs to stimulate research and capacity development in this subject. And there's therefore still a lack of coordinated tertiary education in this field. Thus, the objectives of this program are to provide participants with exposure to these transferable data science and machine learning skills that are commonly used in astronomy. The events that we implement aim to introduce these concepts and skills by having participants work on real-world big data problems in the fields of astronomy, as well as big data health and big data agriculture, as well as to expose participants to the broader applications of data science and big data in industry. During our events, we also incorporate the development of soft skills that are needed in both academia and in industry. So these events that run as part of these programs all make use of the ILIFU Research Cloud Facility, which is a African research cloud, with all the technical setup and support provided by members of IDEA. So as I mentioned, IDEA is the Inter-University Institute for Data Intensive Astronomy, and was developed in order to allow for research using astronomical big data, and is currently used to process data from the NEARCAT telescope, which is a South African precursor to the SKA telescope. So for the big data schools and hackathons, which we implement, we use customized virtual machines on the ILIFU cloud, which are provided by IDEA. Accounts are generated for the participants for each virtual machine, and participants then access the hackathon or school projects via a Jupyter notebook interface. This is therefore an excellent example of how research infrastructure can also be used for development purposes, such as the ones run as part of this program. In the next 2 slides, I will present the capacity building initiatives of the program, namely the Big Data Africa Schools and Big Data Hackathons. Both events are aimed at final year graduates, as well as postgraduate students from various STEM fields, also including young professionals who are working in industry. The Big Data Africa schools are held over 10 days and feature a mixture of formal lectures on data science and related topics, intensive project work, and as well as industry and career skills development. The school teaches important techniques for working with large data sets and focuses on group learning and working with real-life big data, in addition to things like networking with peers and people or contacts from industry which are invited. There's also a focus on industry skills development via guest presentations and workshop sessions, where the aim is to expose students to the broader applications of data science and big data beyond academia, as well as the professional aspects of working in the private sector. The Big Data Africa School was run each year since 2017, with the exception, of course, of 2020 due to the coronavirus. So in addition to the Big Data Africa Schools, the program implements DARA Big Data Hackathons, which have been run in various SKA African partner countries since 2018. These hackathon events are shorter, so run over 2 to 3 days, and more focused events which aim to provide exposure to data science and machine learning techniques, as well as grow confidence in applying these techniques. And this is achieved by having participants work on interesting projects that make use of real-world data. The hackathon events consist of talks given on various topics in data science and machine learning, as well as presentations by invited industry experts. Participants then work through guided tutorials which are relevant to the hackathon project with the assistance of ample tutors. And they then work in teams to tackle a hackathon task. Toward the end of the event, teams present their findings and a judging panel then awards attractive prizes to the top teams. Since the start of the COVID-19 pandemic, these events have also been successfully adapted to fully virtual or remotely hosted events. So these are just some example projects, big data projects that were developed for both the schools and the hackathons. So we have examples of commercial projects such as building movie and music recommendation apps, and then projects that are related to astronomy, such as distinguishing between astronomical detections and radio interference, for example, and exploring radio data in the search of interesting possible extraterrestrial signals. There are also COVID-19 related projects involving the sentiment analysis of COVID-19 related data from Twitter. And then sort of development related projects such as post-cyclone flood analyses using satellite imagery, and many others as well. So here we show some of the preliminary impact analysis work that we've done following the events. So for each event, pre and post event surveys are sent out to all participants, and the results presented here are a compilation of the responses from 40 participants. So we see that attending the event has influenced their perspective or planning regarding their studies as well as their career options. And more than 70% of the participants felt that they had gained a lot of skills and knowledge, both in the fields of data science as well as machine learning. But looking at the responses, the actual responses to the questions on how attending the event has changed their perspective with respect to their careers or their studies, also provides a lot of insight into what attending the event has meant to participants, as well as the positive impact that attending the event has had on them, and also highlights the desperate need for these initiatives in Africa. So just leave this up for you to read for a few seconds. All right. So I'll end with a few concluding remarks and some of the future goals of the project. So we find data science skills development to be highly relevant, and not only for development challenges, but also to equip Africa to face the fourth industrial revolution. And we also find that there's a hunger among many of Africa's youth studying or working in STEM fields to acquire such skills so as not to be left behind. We have developed a model of a broad skills development program, which has been shown to be successful, versatile, and adaptable to various needs and scenarios. We are building a database of big data projects, which can be easily reused by others and openly available on the Dara Big Data GitHub repository. In terms of the future goals of the project, we aim to improve the percentage of female participation in the events by putting into practice various recommendations that were recently set out as a result of a case study conducted by Sereo. We also plan to develop resources and infrastructure that will allow for the hackathons in particular to be independently executable by a much broader community, including various institutions or private groups across the continent. So thus allowing for the project to become scalable and sustainable in the future. So with that, I'll end, and thank you very much for your attention. If you'd like to know more about the project, please feel free to get in contact or have a look at the links listed. Thank you very much.